Let's get started. So welcome to our talk. This is going to be how we can achieve data interoperability with real-time stream processing on top of Snowflake. So before that, I'll introduce myself a little bit. I'm Alkan. I'm a software engineer in the streaming ingest team at Snowflake, primarily focusing on the background services like cleaners, file migration, clustering, and some query performance optimization related to streams. Before that, I was at Robinhood doing data infrastructure and mainly focused on data ingestion and streaming there too. So what is streaming at Snowflake? Well, I want you to remember these 4 key themes with Snowflake streaming. It's very easy to use. We're going to be mainly using SQL. We're going to unlock more workloads through reducing the latencies, and the streams are going to be tied really well with the rest of the ecosystem. What that means, I'll get into that. But ease of use means that you define the tables. So we have something called dynamic tables, and that allows you to define what the outcome of the tables should look like, and you don't worry about the transformations. So the focus is mostly on the data, not the pipelines. And this allows us to do incrementalization wherever it's possible and full refresh if it's not. So the creation of these pipelines as easy as writing a select star query. We mainly use SQL. This makes it more accessible for a variety of our customers and allows us to do more optimizations on top of these processings. Overall, I believe that SQL also reduces the total cost of ownership because you don't need to learn a new API or a new framework, or you don't need to manage an entire different system. And Snowpipe streaming is our offering. It's our way of doing ingestion into Snowflake. This is our key to unlocking 1 minute, less than 1 minute end-to-end latencies on top of Snowflake. This will also, by choosing the latency spectrum, you are also able to make decisions with respect to cost versus latency. On top of that, there won't be any orchestration necessary, so you don't need to worry about dependencies and all of that. This will all be done automatically for you. And finally, the ecosystem. What that means. Snowflake is built on the idea that everything connects really well with all the offerings. Streaming ingest and streaming is no other team on that. It all well connects with your governance, data governance strategy, data cleaning strategy, and on top of that, it's easy to run AI, ML, LLM, and search on top of that. And what we have is that we have Iceberg tables enabled as well on top of the typical Snowflake table format. So if you want some openness and then achieve streaming ingest on top of that, this is possible. So for this, I don't want to go too much into the detail on how we did it. I want to go into the demo because I think that's where the fun is about this talk. In this demo, we have some Reddit posts that I scraped off by finding out the latest 100 posts in a given subreddit, and we're going to be streaming ingest into a table in our Snowflake account, and transform them using dynamic tables, visualize the data, and build a search application. So this will involve invoking some LLM functions and showcase that how easy it is to build an application on top of Snowflake that's going to be streaming. So real-time applications built very easy. And so what I did was that, these Reddit posts will be ingested using Snowpipe streaming. So this is our way of doing ingestion directly into the table. So this is our way of doing exactly once, where the latency the data becomes available in 2 to 3 seconds. And so your queries will be able to see the fresh data right away, prime for analysis right away. And with this API, we expose 3 different API calls: open client to set up the necessary authentication, open channels to bunch of to tables, and then insert rows into these tables that will get uploaded and become available for processing later on. Then we'll do the transformation using dynamic tables. here, this is typically, if you are familiar with the medallion architecture, you can do the silver and gold layer on top of here. You would be preparing the data, cleaning and enriching in this step. And this will create a bunch of, this will create its own dependency graph that's managed by us directly. So you don't need to define any of these dependencies. Of course, these definitions use the select from table definition. That's where the dependency is derived from. And then this introduces two key knobs. One of them is the target lag. This is what determines the lag of this pipeline and how often we're going to run the incrementation step, as well as the refresh mode, which is like, are we going to process this entire table over and over again, or are we going to incrementalize on just the delta so that we don't waste any compute unnecessarily? All right, and then during this enrichment step, I wanted to showcase, well, how can you run AI on your streaming data? Well, I believe this would be the easiest way, because calling LLM functions is just a simple function call on Snowflake. And building a search service is just another query that you set up, runs, and it automatically works under the hood. So let's get right into that. Let's get into the demo and showcase what's going on. So if you're familiar with Snowflake, this is our worksheet. So when you pull up this one, all you need to do to start with streaming ingest is to set up your public key. You can follow the docs on how you can generate that one. But you set up your public key, and this will be used by our client SDK to connect and talk to this deployment so that you can start ingesting. The second step is to create your table. In this one, well, okay, to get back on that, I wanted to do a Reddit post because I want to showcase the power of LLMs. So I was thinking, all right, this conference would love something related to data engineering. It turns out Reddit data engineering subreddit is not that engaging. It's not that fun. I looked into that. So I decided the second best thing, which is the politics. With the upcoming elections, I thought this will become an engaging and interesting subject. So I ingested post data from a bunch of subreddits from various different ideological groups and started analyzing them. So this is what this is about. So we created this Reddit politics post table. It has a subreddit. I don't know. Yeah, I think that looks big enough. Yeah, it has a subreddit, author, title, self-text, when it's created, all that stuff about Reddit, about the posts. So once you create this table, it's empty. You need to start ingesting from the client SDK. Going back to the client, I created this Java application to fetch data from Reddit and start inserting into this table. Basically, to do this, all I needed to do was create a dependency on our ingest SDK, which basically pulls out all the SDK that we have, which on the background will handle all the necessary stuff to stream into a table in Snowflake. And to use this, it's very simple as well. I did a bunch of stuff to get the authentication token from Reddit, and then define the subreddits that I'm going to pull the data from. And what needs to happen is that we open a channel to our table. So for each of these subreddits, I opened a channel and then started collecting the newest posts by periodically polling the Reddit API. In the end, what I do is I'll just insert the rows into this channel, and automatically, within a couple of seconds, this post will be available in my table. So I let this run on my machine for the weekend and started collecting the data. So let's see how that looks like. So if I query this one, so this is the Snowflake UI. You'll have some post ID, subreddit, author, title of the post. You'll be able to see what that was about. URL. Most of these posts do not contain the description. They just post about the URL, and people start discussing in that. Typical Reddit stuff. There are different ways to model this one as well, but I went with a simple one. Keep in mind that these are Reddit posts, so there is no filter to these ones. So if you see something, please disregard that. Yeah. But this is actually primed for analysis right away. Now that we have this raw data, let's see in the last 3 days what happened with the number of posts on the activity depending on the subscriber counts. You can see that our politics had 8.6 subscribers and had 829 posts. Kamala Harris, on the other hand, with the 76,000, had significantly more posts per its subscriber count. This might suggest, people who joined that subreddit is pretty active on Reddit these days. That might tell you about the demographics, or there might be some campaign going on as well. So even with this raw data, we're able to query and analyze that right away. But this is not enough, right? We need to transform this data. We need to enrich it to unlock even further insights from this data. So we are going to define some transformations using dynamic tables. In this step, we'll do the data preparation and enrichment, typical like a ETL process. So there are a couple of important steps here. One is that we create a dynamic table, and we're going to define these 3 parameters. Target lag is how it's going to determine how often do I need to run the delta processing, and warehouse is where that is going to get processed, and the refresh mode is crucial as well, because that's how you avoid the unnecessary computations. So in this transformation model, let's define some tags. Define the subreddits as left, right, or center. Extracts the URL source so that we can showcase how often a source is referenced in a subreddit, and also prepare the post content to be used by LLMs. Like combining 4 different information into a single column, which will get passed into our LLMs. So once you create this table, it will, since we define it as downstream lag, what we do is on the background, we will derive this downstream lag using the downstream dependencies of this one. And I'll get to that later on. Like in a different table, we'll have a different table that will have a target lag of 1 minute. In that case, the target lag of this table also will become 1 minute as well. And I'll show you in a dependency graph, and that will become more clear there. But we just defined the transformations, and what Snowflake on the background is going to do these transformations for yourself. All right, let's define a different dynamic table. In this case, let's do some aggregation so that our BI tool and dashboard is going to run efficiently. So in this one, I want to group by the political orientation and the hour of the post, and then count them so that my dashboard can track the activity of each of these groups over time. And that's going to be an efficient query. And you can easily define such dynamic tables. And then, for example, this is a dashboard that maybe you just need 10 minutes of freshness. In that case, you can choose the target lag as 10 minutes, and it will run your ensure you have 10 minutes of freshness in your data. So once you have that, well, you can actually start querying this as well. But I wanted to showcase you this in a dashboard. So this is what it looks like. For example, if you create this dashboard, you can see the number of posts in a given subreddit in these duration dates. So this is a filter on top of these dashboards that you can choose. So you see the number of posts in each of these subreddits. And on the right, you can see the activity, how it moves over the weekend. The peak happens at 16:00. This is UTC, so it's 9 a.m. here. So you can see the peak number of posts are posted on 9 a.m. on Pacific every single day. And then, it goes down in the middle of the night where no one posts about politics for some reason. Why would they? But yeah, so this is the demo for that. And then what I wanted to showcase is where I think the magic happens. We can now enrich this data using LLMs. But what does that mean? Like, how do you actually use it in production? Well, you can use it in a dynamic table and give it to ask some questions. Stuff like classifying the text of the data. So you can ask it if this post is left, right, or center leaning. You can ask if this post is suitable for work or not suitable for work. So you can use LLM to basically filter out some posts that might not be okay to share in a slide like this. So you can actually use it to filter it out. In fact, like I was talking to my colleague about this, this is Reddit post. Isn't that dangerous to showcase? You know what? Let's implement that filter. Let's ask LLM if this is suitable for work and not suitable for work, and then filter out things that are not suitable for work. And then within minutes, my table definitions were updated, and I can now have mostly the trust, not 100%, this is still LLMs, but still have a good confidence that it filtered out not suitable for work. So there are like a bunch of these different function calls that we can now. So classify text is one of them. You give the content that you're going to classify, give them a bunch of classes, and we're going to use that classes to determine the most likely outcome of them. Sentiment is pretty straightforward. It tries to find out positive or negative sentiment and gives it a value between -1 and 1. Summarize is going to summarize the content for you. But you can also build your own type of functions. The complete is what you are used to with the chatbots these days. You can post combine the post content and say, all right, reply back to this Reddit post with a witty short response. And it does get witty and very edgy with these responses. I can showcase some of them, not all. You can ask a different question as well. Is it left, right, or center leaning? And ask it why, because it will do the reasoning there too. And what I love about this one is this one. It asks you to give a 5-word summary of this one, and I use this a lot because when I was doing this demo, I realized it's really hard to read the entire subreddit, so you can actually just make it 5-word summaries and then understand what's going on in that post. And then, I tried this one as well, to generate tags of them, to showcase it as well. It got some results, but it wasn't in the format that I was interested in. But the results, it got generated the tags, but it was I probably needed to do a little bit more prompt engineering to get the format that I want. So what does that look like? All right, so let's look at some posts and see what it answered. So let's see. Okay, actually I was going to showcase it on the dashboard now that I think about it. So let's look at the top positive sentiment ones. So I sorted this table by the sentiment going down. The top positive sentiment was, a post in the Trump subreddit about Joe Rogan talking about it, that it was a very wonderful podcast. Everyone had its own opinions, of course, but the sentiment there was positive. You can try to look at which of these subreddits are liking and what are the top sentiment ones for them. You can do these kinds of analysis there. Now, each subreddit would have its own, sentiment analysis, so you'll be able to get some model that will give you that. Another interesting thing that I got was that, I wanted to look at which subreddit is talking about left according to the model. So I wanted to showcase that in these dashboards. In the Kamala Harris, for example, subreddit, there was about like 829 posts. Most of them are left. Although I realized an issue with my model here, which is I introduced a bias by adding the title of this name of the subreddit. So that might be why this is so skewed. But also, it's not that surprising that in the Kamala subreddit, it's mostly left. Whereas, in the right, it's mostly about right ideological posts. Of course, these are the ideas of the model, not me. Yeah, so this is what we have built on. So basically, you're able to ask questions, get answers, and showcase and do your analysis using LLMs. And this is done on a streaming fashion. So I believe this would be a very easy way to achieve streaming on top of that. I wanted to also showcase how you can do the search on top of this one. So basically, we have something called Cortex Search Service that you can define on top of your table, where you choose the post, like where you want to search on. You choose the attributes where it will do the sharding, and it will do a fuzzy search for you. So now that you have defined this, this will also work as like a stream where it gets updated automatically depending on the source definition table, which in this case is this LLM enrich table. And for example, for this one, I just want you to search suitable for work posts. For example, this is like a real use case that you can use LLMs for them. And now you can do the search. For example, if I search for California-related post, I can do that. Oh, sorry. Just choose the entire thing. I can find out posts that are about California. If I want to search maybe things about CNN interviews, I can find that as well. Yeah, so seeking full camera Hermes interview, fact-checking Trump's event cancellation claims, CNN guest removed for insult. You know, the short summary is also from LLM as well, so that's why I was very happy to not read this entire thing about the huge posts that people are posting on the right. Yeah, so I know we mentioned Iceberg. Unfortunately, when I was setting up my demo account, I lost access to my AWS account, but this would have been easily done as an Iceberg table if you just added the keyword Iceberg and defined the external volume, catalog, and the base location. So it would be a very simple way to ingest your data into Snowflake, enrich it with dynamic tables using LLMs, build real-time dashboards, and also at the same time, have it as an Iceberg table where you can do further analysis by using any of the tools that you want. Right? That's it.